Okay, good morning, everyone. Welcome to the third day of the conference. We have a very busy schedule this morning on the interoperability with other standards, and we will have 8 presenters presenting. Actually, we will have more than 8 presenters, but we will have 8 presentations. And we, as yesterday, are split into 2 parts. So we will now have the first 4 presentations as planned. And we will start with Marco and Laura presenting us elements related to the SDMX ontology. So, Marco, the floor is yours.
Good morning, everybody. I hope you had some space left after the dinner yesterday, because we're going to give you some food for thought. Another kind of food, but it could be filling. We hope it's nutritious anyway. So we are talking about this SDMX ontology work, which has already started, thanks to Laura, to Danny Ghaffari from UNEP, and there is a task force ongoing, and we are going to report on the first results, asking also for possible volunteers and experts who might like to help us. So this would be very welcome. What I would like to say, this work is, in a way, it follows a red thread from the beginning of SDMX. One of the first pilot projects I was mentioning on the first day was the metadata common vocabulary. And back in 2002, we were actually using this slide. We said it would be perfect if only people all over the world would try to understand each other. The problem is to get everyone to speak Norwegian. Like we do. This is what we used in 2002 when we set up this project, Dennis Ward of OECD and I, to provide a common standard set of definitions of metadata terms. And for us, this standard language, of course, was not Norwegian, but it should have been SDMX. Now, what we are proposing now is a step forward. Let's say, after having a glossary of metadata terms, a simple glossary, the next step would be to create something still at the logical sense, but a more formal language, which is also able to provide relationships between the elements. So we're trying to move towards what is called an ontology. Some of you are very common with this term, others might not be. So first of all, I want to kindly ask Laura, what is an ontology exactly?
Yes, okay, thanks, Marco. So an ontology is an ancient word that came from 2 Greek words, ousia and logos, that is substantially the science of being. So an ontology is a way to represent the reality that can be a statistical domain or, in our case, SDMX. I know what you are thinking now, that we already have a language to represent SDMX. We have the information model that is represented through UML. But an ontology is much more than this, because it is much more expressive than another modeling language. So you can really represent the reality. And it's not all, because you can, the ontology can be translated into logical rules. And this gives you the possibility to query data using a language that is called a SPARQL language. It's a declarative language like more or less SQL, a little bit more complicated. But the important thing is that you can query using the semantic that you have used to define the ontology. And it's not only this, through these logical rules, you can also infer data. So you can discover knowledge from the knowledge that you already have. So it's very, very powerful. Of course, in order to query your data, you have to create a correspondence between the ontology and the data that you have. So this gives a lot of opportunities. First of all, the SDMX standard is more understandable because it's well represented. Second, of course, you can use in an architecture machine to machine. The most important thing is that you can query using a semantic, and when you map your ontology with the existing ontology that are related, for example, to SDMX or in general to statistical world, then you can query your data using other semantic. So this is a very added. Okay, this is the use case, no? You can, no? I think that you have missed the real use case. Okay, this is not important. You can go to on the other. Okay, this is a use case. This is not a real use case, it's the architecture of a use case, but you can imagine, for example, to query the SDMX global registry without doing click or to follow the graphical user interface, or without to implement a complex SDMX query. Okay, then you can have an SDMX ontology, you can create a correspondence with your SDMX global registry, and this piece of software that is called the Reasoner transform the ontology in logical rules. And you can query your data semantically using the words that you use for SDMX. So for example, give me the codes of this code list and so on. So it's very interesting. And if you do a mapping, for example, as we did with SCOS, then you can query, for example, by SHOVOC, you can perform a query and retrieve data from the global registry. Okay. Okay, vabbè, fa niente. This is the task force. The objective of the task force were, first of all, define use case, understand better the context and the potentiality of the ontology. Then it was mandatory to reuse existing ontologies and, of course, implement an SDMX ontology. Okay. Sorry, Marco, can you go? This is what you have already said. Our task force has unlimited seats, so if you wanted to contribute, we are very glad, we are very happy to welcome you. Okay. So what we have done for until now, we have done a survey of the ontologies, and we have fit this ontology to SDMX building blocks, because ontologies can be specifics for certain building block. For example, SCOS and XCOS map well the item scheme building block, while DataCube vocabulary map better the data structure definition building block.
And there's also a problem of versioning there, because DataCube vocabulary was elaborated based on SDMX 2.0. Now we are with SDMX 3.0, 3.1. So for those who are experts of the information model and the standard this tells you something, there should be also some work before doing this mapping.
Yes, the versioning is another issue. So, and also we have done a prioritization of SDMX. So we started by item scheme, category scheme, and so on. And to this block of SDMX, what we have done a mapping that is the most difficult part among the artifacts of existing ontologies and the SDMX artifacts. This is very difficult because you don't have a one-to-one correspondence usually. For example, a concept scheme in SCOS is a superclass of the concept scheme in SDMX because it includes also classification, list, and so on. So it's very difficult to semantically perform this mapping. Then, of course, we have implemented the SDMX ontology, we have implemented the mapping, and we also have tested using some tools that we have in use actually to create a correspondence with a simple SDMX database in order to query and to test the ontology. And we have tried also to perform query using the other semantic, and it runs, so you can trust on me. It's a very good result. Okay, so the recurring action we will have also for the future, and we will apply to data structure definition, and we will map with data cube vocabulary and DCAT and StatDCAT ontologies. But the first point, it's very crucial. Marco, if you can click, sorry. It's a critical alert. We need absolutely to provide an assessment of what we have done, because the ontology grow exponentially, so it's better to have a clear basis on which to move on. So we would like to involve experts, both on ontology then on SDMX, to check our work.
And in particular, because in some cases we realize that there are some definitions which are not exactly the same between what is written in the information model, what is written in other parts of the standard, which is the XML documentation. So we wonder also what is the authoritative source for these terms in SDMX. So there is some issue to work on.
Okay, so the last, if you want, these are the useful links where you can to download what we have done, mapping, ontology, and so on. And if you wanted to reach us, you can write to Marco and me, and we will. Thank you.
Because some of the information is on GitHub, is restricted access, so we should give you access so that you can retrieve everything.
Thank you very much for the attention.
Thank you very much for your interesting presentation, and those who are interested to participate in the task force, please remember to talk with Laura and Marco during the coffee break. Now, going to the next presentation, unfortunately, the colleagues with Indonesia are not with us physically in the room, but they will be connecting virtually to this meeting. So I hope the connection is working. And yes, we can see you on the screen now. So please feel free to start when you are ready. Okay, we can see the slides, but unfortunately we cannot hear anything at the moment.
Okay, good morning, ladies and gentlemen. Can you hear me?
Yes, we can hear you now.
Okay, thank you. Good morning. My name is Tri Listianindrum. I'm from BPS, Statistik Indonesia. I'm sorry for not being with you all today. Today, on behalf of my team, me, Vincent, and David, I will present our experiences in building the statistical data standard, particularly how we combine statistical ontology with the SDM extractor. So, ladies and gentlemen, let me begin with the background. So there are two main backgrounds for our work. The first is the Law of Statistics, released in 1997. And the second one, the one is more recent, is the One Data Policy in Indonesia, which is released by the Presidential Decree number 39, 2019. And it is stated in the decree that to produce accurate, updated, integrated, and accountable data, it needs to fulfill 4 principles, namely data standards, metadata, data interoperability, and the use of reference codes. So the One Data Policy is a mandate for BPS to develop the statistical data standard, or we can say it SDS, statistical data standard. And now what is SDS? SDS is basically a set of standardized concept, definition, classification, measurement, and unit of measurement to produce standardized statistical data. So when we design the SDS, we also get a reference from another best practice from another countries, namely, for example, from the Statistic New Zealand, and also from ABS, how they develop standard, and also from Statistics Center Abu Dhabi, and also from Palestinian Central Bureau of Statistics, or PCBS. But finally, our final structure is not replicate any of those model, but we have our own unique structure of SDS, which comply to the presidential decree with content of 5 components, namely concept, definition, classification, measurement, and unit of measure. So here, the first one is the concept. It is different with the concept we say in the SDMX because it refers to statistical term. So it represents the generic idea of a data, and then definition is a description about a data and also the scope and the boundaries of data. And then classification is a standardized disaggregation to present the data. And the other two is measurement and unit of measure. It is used for maintain the data comparability and interoperability. In constructing and implementing SDS, there are 3 roles that we define. Actually, it is also in the One Data policy. There are 3 roles. The first is the data producer, and data supervisory, and data trustee. The first one, data producer, is the units in the government institution that produce data. And then data supervisory is the units that appointed to compile data and also to disseminate data. And the last one, data trustee, is BPS. So BPS serve as data trustee for statistical data, but for other data, it is another institution. And then for the process constructing SDS, the first one is during its formulation, its institution submits its own proposal of SDS draft for the data, and they submit it through the data supervisory to the BPS, and then BPS do the review and also compile and accepting the SDS proposal, which qualify, and then set it as SDSN, or we can say national SDS that we set as a regulatory. And then once it's established, the SDSN or the national SDS, it is referred to all government institutions. So all of the statistical activity that is conducted by the government has to refer to SDS. And then the data is considered to be standardized when its metadata consistent with the SDS that is already implemented. And then after the data standardized, it will be easier to interoperate across all government institutions. So now what is the differences and the relation of the SDS and SDMX? The first one, SDS is used as a guideline for data producer on how the data should be produced, while the SDMX is used as a standard format for reporting and dissemination. And secondly, SDS focus more on consistency of concept and definition. So it's like semantic and also linguistic. But in the SDMX, it ensures the data structure consistency because of the standardized format. And the scope of use, SDS is used across government institutions in Indonesia, and SDMX used internationally. So actually, the integration of SDS and SDMX will amplify and enhance the impact of standardizing statistical data in data production process. And then how we further explain the relation about SDS and SDMX. The first, concept and definition will be treated as reference metadata. And then classification in the SDS will refer to SDMX Global Registry if it exists. If it doesn't exist yet, BPS will create code lists corresponding to the existing classification. And then for disaggregation, it can use the code list combined with content constraint, because in SDS, we only standardize the classification that meet some principle. For example, mutually exclusive and also exhaustive. And then the measurement and its unit will refer to SDMA code list as well, combined with the unit of multiplier. And then the overall SDS will be constructed as general DSD. And meanwhile, the content constraint formal data view will be created as data flow. And here is some practical example that we already implement in the SDS that refer to SDMX. In this slide, we see some of the classification that is also already standardized in SDS. For example, we also standardize the classification of sex, which also appear in the SDMX code list for sex. And in the SDMX, it is stated that the domain value is M and F. We also adopt the codification M and F in the SDS. But for the attribute, we use Indonesian language. And other classification that also in the SDS is classification for institutional sector, and also marital status and degree of urbanization. And we see here, we have the codification for the SDS. It consists of number, and the first three number is referred to the CSA, classification of statistical activity. And in this slide, we see the data or indicators that appear in the SDGs CL series in the SDMX, and we also standardize it in SDS. We see it is just a few of the example. For example, we have here infant mortality rate with the CL series. This is the code, and we also standardize it in Indonesia, in Bahasa Indonesia, angka kematian bayi, and it is completed with the international name infant mortality rate with the code for the SDS. In standardizing, yes.
Sorry to interrupt you. Can I please ask you to accelerate and move to the conclusions, because we are short on time.
Okay, thank you. This is the last example actually. So in the SDS, we standardize it by using it in a regulation. For example, here the components: name, concept, definition, classification, measurement, and unit of measure. And then our challenge and future development, for example, we have the challenge to determine the scope of data standardization and increasing awareness and participation in government agencies, and also increasing the completeness in SDS. And the future development, we see the possibility to set it as national registry, and also fully implementing the SD, and also using the SDMX as a tool to implement in One Data Indonesia through consolidation of SDS and statistical metadata. Okay, thank you. That's for me. Thank you for your kind attention.
Thank you. Thank you very much for your very interesting presentation. And let's move immediately to the next presentation from Jan on the geospatial elements. Please go ahead.
Thank you so much, Marek, and good morning, colleagues. I'm Jan Burdziej, representing Frontier Data and Tech Unit from UNICEF's Data and Analytics. And my goal for today is actually twofold. First of all, I would really like to highlight the importance of geospatial dimension in our statistical data, but also I would like to share some of the work that our team at UNICEF has been working on to how to bridge the gap between geospatial and statistical data. So let me start with a hopefully not too controversial statement that spatial is kind of special. And I will share a couple of quick examples to back up this statement. let me try to wake you up with a quick quiz. Does any one of you have any ideas of what these two numbers may be representing? Perfect. So you already see the, how powerful geography is, because by looking at two numbers, like many of you already were able to identify that these are actually geographical coordinates. And in fact, as many of you have mentioned, they actually point to the middle of our conference room. But we don't really need such a high precision, right? So let's just round up the number so it takes less space on the screen or in our database. So if we round up the value, well, our pin on the map actually moves 60 kilometers northwest and points into the field close to Ladispoli. But there are some more complexities. I don't know if all of you are aware, but actually there are hundreds of datums and coordinate systems. And what if these two numbers are actually coordinates in a local Rome Monte Mario coordinate system? Well, in that case, our pin would be pointing to a nice mountain range in Bulgaria, because this particular coordinate system is using different primary meridian. And of course, this is an edge case, right? But what about if someone just missed to add the hemisphere indicators, and these two numbers are in WGS84, which is the most commonly used coordinate system, but it's actually 42 south and 12 west. Well, now we are in the middle of Atlantic Ocean. So, and if you are saying that, well, these are really, it's not happening anymore, I can ensure you that this is actually happening. Before the UN, I've been working in the oil and gas industry, and we had a nice story about how an oil rig has been towed to a different side of the equator because of exactly the same mistake that someone has made. So going back to statistical data, so how the geospatial, why geospatial really matters when it comes to statistical data. And I would say there are a couple of things. So first of all, maps, and there is scientific evidence that maps helps people understand the data better. Maps help us overlay statistical data with other data sets like climate data, data on floods, earthquakes, whatever. But also maps helps us uncover spatial patterns, which otherwise without the map won't be easy to spot. So just look at the table that shows this, tells a story about the child exposure to droughts, and then look at the map. See how quickly we can grasp the situation just by looking at this image, right? And there is a saying that one image is worth 1,000 words, right? I would say a map is just a geo-referenced image, so probably even more than 1,000 words. And of course, also I wanted to mention, by having properly geospatially enabled statistical data, it also makes it more AI ready. So, I'm pretty sure that everyone has seen this map, right? So I would kind of argue that maybe even this is one of the most commonly accessed geospatial product. Actually, like a data-driven product, and which had like at some point more than 1 billion hits per day. So I hope that now by now everyone is kind of convinced that spatial is important. So how this translates to our SDMX data? So what are the key challenges related to SDMX, to mapping SDMX data? Well, first is usually identifying the proper geometry, proper shape files, boundaries that our users can use to plot our data against. Then even if we have the boundaries, we have to link the data to the boundaries. And as you can imagine, linking by names, it's very often tricky because of different spelling. And of course, if the boundaries are managed in different places than our statistical data, very often in many countries, we have different codes. So then it becomes really, really challenging. And of course, there is another aspect. Usually maps allows us to show like one particular combination of all the dimensions that we have in the data. So there is this flattening of our multidimensional structures into more simplified data. And of course, time dimension adds another complexity. I will now give you a very quick tour of the two platforms that we've been working on at UNICEF, GeoCite and GeoRepo, and how they connect to SDMX data warehouse. So really quickly, GeoCite is an open source web mapping platform that is specifically designed to handle and visualize subnational country level indicator data. It's open source, and I will just give you a couple of screenshots just to give you a taste of how the platform looks like. Users can easily navigate across admin levels, across the time dimension, but also visualize data using different methods, also bringing and overlaying data from other sources like heat maps and so on. Also three-dimensional visualizations. Additional filtering, the ability to combine multiple indicators and identify hotspots on the maps, and so on. The second platform is called GeoRepo, and think about GeoRepo as like a dedicated, specialized geospatial code list manager. So with all the complexities behind geospatial data, GeoRepo helps us manage administrative boundaries which are versioned and are also exposed through APIs, including some of the dedicated geospatial formats like vector tiles. Imagine that at admin level 2 globally, we have more than 40,000 codes, entities, districts. So think about how your code list would work with 40,000 records, and then add geometry for every single code. You can imagine how complex this is. And vector tiles are one of the solutions how to deal with this complex spatial data. So now it's the final piece, which is how we connect all these things together. And it's called the SDMX connector that we have built together with a bunch of brilliant students from the Harvard Tech for Social Good Society, where we basically embedded the SDMX data browser into our geospatial platform. And this is just a quick implementation, just a couple of screenshots where users, our GeoCite platform users, can browse through the agency data flow. They can even run scheduled jobs to sync the data, filter by different dimensions, and preview the data. And of course, the final result is the data can be easily visualized on the map. So by connecting our SDMX to GeoRepo, ensuring that our code lists have proper geometries managed in GeoRepo, and by connecting the GeoCite with SDMX, we can now easily bring all these data sets together. And in terms of next steps, I mean, this is just the first version. We have some plans for making it even more robust. So we are considering this pub-sub data syncing mechanism, implementing this mechanism, but also thinking about like the real-time live SDMX data visualization. And of course, we want to keep producing more and more subnationally geocoded indicators. So some key takeaways. First of all, if you are interested in any of those platform solutions, GeoRepo, GeoCite, the connector, please feel free to reach out to us and we will be more than happy to talk and explain in more details. And some like more high-level takeaways. I really believe that geospatial dimensions add a lot of value to our statistical data, and sharing ref area codes is not enough for our users to be able to utilize the data efficiently. We have to make sure that users can access actual geometries, boundaries. And you're not alone. There is a dedicated expert group on bridging these two different things together, two aspects together, working under a committee of experts on the global geospatial information management under UNSD. And for those of you who are actually managing SDMX data sets, data registries, think about these two questions. How many of your end users may actually want to map your data? And as of now, how difficult it would be for them to actually make it happen? With that, thank you so much, and over to you, Mark.
Thank you very much for your very interesting presentation. The geospatial data are very interesting, and I am sure we can spend a full day on it, but unfortunately we don't have time, as my colleagues Antonio and Daniel are waiting with their presentation.
Yeah, thank you very much, Marek. And we already had a geography quiz today, so let's make a very short metadata quiz to keep our brains going. So what's the coolest metadata standard in the world? Let me look into the room. Yeah, most of you know the answer, but unfortunately we are not alone. So in some other rooms we get different answers. So what me and Antonio were trying to do now in the next 8 minutes is to show you a bit an approach to integrate with the data point model standard, which is coming from the supervisory world. And just to start, I will start with lining out a short business case from the ECB perspective of why we think it's important. Also why we believe that hostile takeover of other standards is not our business. It is to work with other communities together, and we see a possibility to do so. So why would we do that? In the ECB and in many other central banks, supervisory agencies, we have the challenge that we need to combine regulatory data, regulatory reporting, supervisory financial data with statistics. And many organizations have both of these branches, or some need at least to work nationally together on this data. We have different starting points, of course. So regulatory reporting looks at financial supervision, risk assessment of the financial sector. We have regulators, we have authorities with the scope of financial data. Like in the ECB, in many cases, statistics is in the same institution. Sometimes it's not. But our mission is, of course, to have good quality, transparent data for society. And then the audience is policymakers, is the public. So we have a different scope on what do we do with the data. And also a different scope on what data, because statistics, of course, looks at everything. But many cases you need to combine it then with financial data. For instance, you look at climate risk or green investment, you need to have geographic data available, you need to have certain trends available, plus you need to combine it with financial data. So what is in the middle? In the middle, we have data management and we have business processes that manage data. And suddenly when you go into that layer, it doesn't look so different anymore. We need to describe and model the data. We need to collect and validate it. We compile, produce. Very important, integrate, which I think is a big challenge now. We heard very often with AI about data integration. How can we automate that? And then at the end of the day, disseminate it, analyze it, make our conclusions, and it starts again from the beginning. So if we look at the process, it's not so different. When we look at how the process is worked at, it's very different. And we have the challenge now to combine it. And as ECB, of course, we have the challenge even more because we have this double mandate in the institution. Fortunately, Antonio is here to rescue us, and he will show a bit on how these two worlds can work together, and that we have opportunity for solving this big question tag in the middle. So Antonio, the floor is yours.
Thank you, Daniel. Well, I think that a very obvious question comes to mind, which is if we have two standards for solving the same issue, right? The same business process, why? Is there a good reason for this? I have been working for many years on both fields, and my answer is a personal answer, of course, but is for historical reasons only, which is relevant, of course, right? But the reason is that there are different practices. If you look at the regulatory reporting, normally it is the supervisors defining the data sets. And they are used to seeing forms like the balance sheets and the profit and loss statements and all these kind of things that have been the same for a couple of 100 years, right? This is what they are used to, and this is what they are thinking of. While if you go to the official statistics, I guess you will all be familiar with the data structures and this kind of thinking. This leads to people defining things in different ways. So a supervisor, as I'm going to show you later, will start thinking of the table and then the rest will come. While the statistician will start thinking about the data structure definition, right? And also, for me, I like to see this as multidimensional data only. But it is true that in both worlds, there is more specific views, right? Like subtypes of multidimensional data. Statistical data, there is a lot still of time series based, time series focus, right? And when we go to the regulatory reporting, there is a lot of focus on one unit, so one bank on one date, right? So these are different practices, but fortunately there are some common ground. Everybody realized that the glossaries, intended as the concept plus the code list, basically, is very relevant, and providing a dimensional definition of the data sets is very relevant. So with the next slides, I'm going to try very quickly to give you an overlook of what DPM looks like. This is an SDMX conference, right? So the idea is that you have a bit of knowledge of SDMX, right? And from there, I want to show you what would be the DPM equivalence. This is something that, okay, this is a snapshot yet from FMR, right? This is a data flow we took from the Eurostat. We modified it slightly, but this is something that most of you will be able to recognize easily. To summarize it, some data points could look like this, right? So we have some demographic data broken down by age, sex, geographical area, and we have three measures: population, number of deaths, and number of births. I think that is clear for all of you, right? How would this look like in the data point model? By the way, it's also related to XBRL, okay? But just to focus a bit, to narrow the problem, let's talk only about the DPM. So a supervisor would start by designing the table, right? So how do I want to see this in the form of a table? There are many different ways to draw the same data when you start drawing a table, right? This is just one example where we are having some rows and some columns. This is what is called headers, right? In this case, I have decided to draw this like we have rows with the breakdown of countries and age, and we have column with the metrics and with the sex, okay? The Cartesian product of the rows and the columns is the cells. For each row and column, we can have some labels and some codes. And also, it is important to note that some cells may not be applicable. For instance, in this case, we have a number of births. I guess that the age buckets do not apply here. The second phase is, okay, now we know it's important to provide some modeling. So what the supervisors are doing in this case, or some modelers with the supervisors, are providing some dimensional definition. So for instance, for row 30, they say this is age, this is a bucket between 25 and 74, and this is for Belgium, right? And for column 90, what we have is the metric population for males, okay? Then note that in this case, the time period is implicit. Of course, there is a time period here, but in the DPM, because they are used to seeing this kind of tables, it's implicit. They are not defining it. It's a common practice, right? It's not necessary, but it is like that. Once we have this, we can do again the Cartesian product of all the modeling, right? So that, for instance, if we focus on this cell, that is the table 30, sorry, the row 30 and the column 90, we can create a variable that in the end is composed of what it's called a context, okay? That means that it's for this age bucket between 25 and 74, for Belgium and for males. And we always need to have a main property that would be like the metric, like the measure, right? Which in this case is the population, okay? If you see now, we have reached the dimensional definition that, and if you see, it's in the end is equivalent to what we have in SDMX. Because if we look at this with data, right? This is exactly the same data points I was showing you in the beginning, but in this case, they are rendered in this table. So if we go back to this row 30 and column 90, we are going to find here a figure, a fact, right? And we have three different ways to see this, three different ways to refer to this. One is the table row column. So this is this table with the row 30 and the column 90. Another one is the variable, right? This is variable 223. But because the variable contains all the modeling, I can say that this is the age between 25 and 74 for males for Belgium. And this is strictly equivalent to what we are going to find in SDMX.
Yeah, so basically, what is our objective? Our objective is that we have, of course, we need to be able to consume data. I mean, not only from DPM world, but from many other worlds as well. You will all have your own challenges. What we want to reach is that we started already doing some mapping of terminology. You cannot imagine how difficult it is if you talk to somebody about the concept scheme and they will look at you with puzzled eyes, or even when you talk about the DSD. We had even a code list is not called code list in the TPM world, so it starts already with very basic terminology to understand each other. Then to try mapping the standards, we have done some work there as well by now, but we need to go further to say how how can we converge that we are able to treat all the data, that we are able to consume all the data, and that we can use the strength, let's say, in a kind of best of both worlds scenarios, how we can combine some strength of DPM it has for easy understandability for a supervisor with the strength SDMX has, for instance, to have a good API, to have a good community and so on. We all know those, right? So what we are looking for is how can we manage the metadata in a kind of standard independent way, but then utilizing the standards that we all love. Thank you.
Thank you very much, and thanks to all presenters in the first half of the session. We are very short on time, but we still have a time for one question or maybe even two very short questions. So I see two hands, one there, one there. So please go ahead.
Laura, just a moment. Yes. RDF Data Cube and DCAT. I suppose that you have already known that some experiment and also some study was done in the past concerning the DCAT, StatDCAT, and RDF Data Cube directly in ISTAT. I mean, for those of you that are using for example, the NSI web service of Eurostat of the reference infrastructure, the SDMX API, it is free already a plugin developed by ISTAT where you query using the SDMX grammar, but you can extract, negotiating the format, the RDF XML data cube format. So it means that this kind of mapping was done. And you can extract both in RDF data cube structure metadata and data. Also because the RDF data cube has most of you, or some of you knows, is based on the SDMX information model. So it is very easy to make this mapping. The second part concerning DCAT, also in ISTAT, we presented several times that metadata structure definitions is, with the metadata structure definition, is to map a DCAT application profile. And we mapped the DCAT application profile for Italy. So, but using simple metadata structure definition. And we, let's say, took in consideration when we mapped this, the study that was conducted on StatDCAT. This is just to inform you to not to repeat things that we have done in the past. This is the first question. The second question concerning...
Okay, I'm sorry. It was already a very, very long question. You can take the second question during the coffee break. I don't know if Laura or Marco wants to react very briefly now or during the coffee break. Or...
Yes. Yes. Thanks, Francesco. As you have seen in the timeline, the next step is really the data structure definition, and then after the metadata structure definition. So we are very happy to use the mapping that you have already done. This is very, very helpful for us. Thank you very much.
Okay, and we had also one head here, but please, very, very short question if possible.
Nikolaoutsas from the BIS. The question is for Jan on the geospatial presentation. I'm not sure I understood if you were using already the SDMX geo code list features. That was the question, and if you plan to do. Thanks.
Yes, great question. Thank you so much. So no, we are not using this feature from the latest version of SDMX. We are looking into that, and I'm looking forward to the capacity training for the next 2 days to learn more. Thank you.
Okay, thank you very much. So now I will ask for a change of presenters. Let's hope we have enough places here. So we have managed the transition very swiftly and very quickly, and let's go immediately to the first presentation on a VTL desktop for CASD. So please.
Okay. Can you hear me? Yes. Okay. Thank you, Chairman. Thank you very much. I'm Kamel Gadouche. I'm the director of CASD. So CASD is a non-for-profit public body as a consortium gathering the French National Statistical Institute, INSEE, and Banque de France and universities. So its core mission is to provide secure environments for processing confidential microdata. So I have to move. Okay. And first, which data? So it's raw data, confidential data, raw data from data producer such as, of course, the French National Statistical Institute, Banque de France, Ministries of Health, Finance, for tax data, labor, and also from banking data and from private companies such as Meta, Facebook and Instagram data, and TikTok, and so on and so on. So very sensitive data. Second, it has, of course, to be very secure. So we are certified ISO 27001 for security. And we also, we are the first data hosting service certified officially from the GDPR, Article 42, via the Euro Privacy Scheme. So very detailed data. And we provide access to 2,000 active users, 1,600 are researchers, as you can see on the left, and 400 are data managers, data scientists from institutions. And those data managers produces data sets for all the external users. So among them, one is IRDES, which stands for Institute for Research and Information in Health Economics. And they are our clients, so they came to me because they wanted to they have to prepare and create new data sets from administrative data, and they are used to use the SAS software, and they want to leave SAS, and they try to do the management with R, but they had many memory issues. So I asked them a use case. So the use case is for big data sets of 166 million records of health services. They wanted to transform the data sets, to prepare the data sets, so they do data preparation, and they also have to apply filters and aggregate by patient and quarter, and then pivot by quarters the data sets. So that is the use case, and the challenge was to find another tool to do these operations. And I asked them their expectations. So for their expectations, they also, as it was mentioned many times yesterday, they wanted a user-friendly tool, and so that they can visualize the data sets, the input data set, the intermediary data sets, and of course, the result data sets. They want to manage data sources in folders and or buckets. Of course, they ask for performances because they had many memory issues with R for put all the data in memory. So that was the big expectations, but they also were interested in the documentation and using a standard, international standard for documented the lineage. So what did we do? So we started to looking for a tool for that. And I had a talk with Franck Coton, who's here, and Nicolas Laval from Making Sense. And they told me that VTL could be a very good client, and they were working on open source VTL engine for this. So I give the floor to Nicolas from Making Sense.
Thank you, Kamel.
It's good? Okay. I'm not sure. Doesn't matter. So you have here the okay, thank you, Rafael. You have here the functional architecture of the solution we build with CISD. So you have at the right the UI, which is a kind of friendly UI, modern in React, and that's the whole part the business user will see. All the other PCs are under the hood, are technical PCs to perform big calculations. We have the possibility in the application to read datasets. We support several formats which are listed there. And we missed to mention SDMX because CISD doesn't use SDMX, but we also have the possibility to read metadata in the registry, provide location, and run scripts on SDMX sources. And at this point, we use the implementation of SDMX core from BIS, which is a really nice use case of reuse. How do we perform calculation? We do that through an API in Java. We have a way, the way to work is with Q because calculations are sometimes a bit long. We use Treva's VTL engine and we perform calculation as distributed computation thanks to Apache Spark. I have just one focus on the two tools we maintain as open source at Making Sense. Up on the other slide. And in the UI, oh, okay. In the UI, you have the VTL editor, which is a React component available directly on NPM. And we have so the engine, the name is Trevas, and the main implementation is in Spark, so you are able to distribute it your computation. We also use some other powerful framework such as DuckDB to read database in an efficient way. And I think it's good for architecture. And now it's demo time. So you can see the home page of the application. The home page enables the user to manage projects, so create a new one, importing existing, having some favorites, and so on. When you go in the Hirdes sample, you discover the project page with the editor and the script for Hirdes. At the right, you have the data spaces to link data to the script with a dedicated notation, dataspace.tablename. In a data spaces, you discover your table on your file system. You can open them, you can discover. In a new feature, you will be able to filter, to do some nice things with the UI. You can also play and reorganize your layout if needed. And as I have VTL script and data sources, I can now run my VTL transformation. Before that, I run a preview phase, a kind of semantic validation. My preview is good, so I have a tab to discover step by step in an accuracy way the state of my metadata. For instance, I have a table with 6 variables at this time of the calculation. And I can also have a view, which is a bit strong for this use case, because a lot of variables, but it's a lineage one. So we transform the execution in a documentation with lineage. As the preview is good, I'm ready now to fire the real execution in the distributed environment. So you can discover the script and we will have, so transformation is done. Logs told me that dataset has been written. And I focus in the Tom data space on the LeakitGP table, which is unpivoted. And as you will see, the last instruction of the script is just to pivot this table to have a statistical friendly table. So I go to the output data space and I discover my table, which is persisted and pivoted. That's it. I think we answer to the use case of the researcher, so we can give him the new table.